guys, welcome to Stats Online. Today we are going to look at stem and leaf plots or stem plots. You're going to be able to interpret them today. You're going to be able to compare distributions of quantitative data with stem plots. You're going to be able to make a stem plot by hand. And today we just have the activity, which is just the notes for today, and then you have the application as your homework. Okay, so lesson 1-4 is all about stem plots and some important ideas about stem plots. The first one is please don't ever forget a key. So don't forget a key. Very important. Number 2 important idea is do not skip the stems. And we'll learn more about that in a little bit, but don't skip stems. Important. And so for a stem and a leaf, the stem is first, and the leaf is the last or the second. Okay, here we go. Oh, well, actually, example of a key. So let's say we want to talk about the number 23. We would write 2 dash, or with a line, straight line, 3, and that the 2 is the stem and the 3 is the leaf. Okay, good. So now here is our activity for today, is how many pairs of shoes do you own? So I want you to stop for a second and think, how many pairs of shoes do you own? And it says, how many pairs of shoes do the seniors at Clio High School own? That's a pretty cool question. And then let's use the students in this classroom as a sample of all CHS students, or we could have done all CHS seniors, which makes more sense, but we do have some juniors in the class. So let's just do all students in general. And so it says to record the data in the class here. So you're not in the class, totally fine. Let's still record some data. Let's make this kind of more easy. Let's just do 12 students. And let's say we sampled 12 students and someone said 3, they own 3 pairs of shoes. Another person said 3 pairs of shoes. Another person said 4, 10, 11, 12, 13. Someone said 23. Let's do 24, sure. 25, 31, and 40. Let's double check and make sure those are 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total students. Let's just say we got a small class. Okay, perfect. So is the number of pairs of shoes categorical or quantitative? Quantitative. Well, it is a quantitative variable. It isn't like a category. We're asking how many numbers of shoes specifically, but if we were to say how many students in the class have 0 to 5 pairs of shoes, that would be categorical because we can put them into intervals. Okay, so now let's go ahead and create a stem and leaf plot. So we're going to draw our straight line down, and then we're going to represent all of these numbers. So we have 2 people who said 3, so we would say 0, 3, and then 3. And then another student said 4. Now we need to represent 10 with the first digit here and a 0. So that is 10, then 11, and 12, and 13, and I'm going to stop. Very important when you're creating a stem and leaf plot is that these numbers should line up, because you're looking to see some sort of a distribution here at the end, some sort of a pattern, but these need to match up so that way the spacing is correct when we're looking at the distribution. Okay, so let's do 23, 24, 25. Done. Then we have 31, and then we have 40. Okay, so don't forget to make your key. So let's do that now. So let's say key. Let's do 0, 3 is 3 pairs of shoes. Cool. All right. So we have some questions. What percent of the students in the class have 10 or more pairs of shoes? So 10 or more. So we have to include the 10, have 10 or more. So let's go back. So have 10 or more. So that would be, is it 9? Yeah, 9 out of 12 students have 10 or more. So that would be 75%. And let's go ahead, and that's 9 out of the 12 students in our class. And then let's just describe the shape of the distribution. Now there are different ways to describe the shapes of STEM and STEM plots. So we could say it's symmetric. We can talk about if it's skewed. And skewed left or left or right. And then if there's a peak. All right, so symmetric is basically what it sounds like. You can kind of see that there's some middle ground, and the left side and the right side kind of mimic each other, so it'd be very symmetric. Skewed left and skewed right is all of the data skewed, or most of it's skewed to one way, or most of it's skewed to the other way. So let's go ahead and back over and look at our stem and leaf. And we're going to say that this is skewed to the right. Okay, we have very small amount, just one of them was one of them, and then it comes up like this, and that is actually skewed to the right. Now, some students will kind of turn and look and say, well, it looks like it's skewed to the left because all of the data is to the left. It's actually opposite of that. We call this skewed to the right. So we're going to say skewed right. And then we have a slight peak. We have a slight peak at the tens because the tens there are four there, and the other sides are 3, so it does peak just a little bit. So we're going to say it has a slight peak in the tens. And are there any outliers? We don't have any outliers in our data. That'd be if like someone had, I got 53, but no, 53 still wouldn't be an outlier. 100, right? If I had like 100 pairs of shoes, 104 pairs of shoes, I mean, I'd like to see their closet, but that would be obviously an outlier, and we do not have any, none. Okay, short notes for today. That's a stem and leaf plot. You're going to be able to do some in your homework today from scratch, and I hope you guys are having a great day, and I'll see you next time. Bye.